Okay, now we are beginning the anti-differentiation. You don't need to say anti twice. Okay, so now we're finding an integral. And now you use uppercase f of x is equal to, this is the integration symbol accompanied with a dx or a dy or a dt or whatever the variable is. And if you have a x to the n, this is the power rule that I'm going to explain to you. So you're going to do, it's the reverse of the derivative. Remember, if you had y is equal to ax to the n, the derivative is you bring the n down in front and multiply times x and then n subtract 1. Well, think about the reverse of that. What's the reverse of multiplying? Dividing. And the reverse of subtracting is adding. So, but because it's the reverse order, you have to do the addition first. So this is what I mean. So if you have this ax to the n, first of all, we always pull the constants out. In fact, the constants can come outside the integration symbol. And this is indefinite integral, so we don't know our lower and upper bound yet. We don't know that, and I'll show you what happens because of that. Once we have this simplified, we can remove this. Here's our a, and now we start the anti-differentiation process. We add in plus 1, and whatever this adds up to, we divide x by that value. And because we don't know, so if you've got a graph that looks like this and we care about the area, right now we're just doing the form. We don't know what the a and b is. So indefinite integration just gives us a formula. So later on, if we have an a and a b, we can plug that in. And because when we take the derivative of a number, since the derivative of a number is 0, when you work backwards, you assume that 0 exists. So the backwards of 0 is a number, and we call that number plus c. So that's what we did here. We removed the integration symbol. The a was on the outside. We put all of that in parentheses, and we added 1 to the n, and we took that whole sum and we divided that sum. So let's go ahead and do an example so you know exactly what I'm talking about. So here's the constant, so I'm going to say uppercase f of x is equal to the indefinite integral. The 6 is going to come out front, and then the x squared, and then I'm going to put another set parentheses for the dx. Well, that's as simplified as I can get it. So now uppercase f of x, I'm going to put a 6 on the outside of parentheses, and so I don't forget, I'm going to go ahead and put plus c right there. And see where this says x squared? I'm going to put the x squared, and now I'm going to add 1. 2 plus 1 is 3. Well, we can simplify that. Well, 6 divided 3 is 2. So x cubed plus c. And remember, c is just a constant. And how you know you did it correctly is take the derivative. Well, that would give us 6x squared plus 0. And then look. That's how you know you did it correctly. And that's the fundamental theorem of calculus, is that the derivative of the integral brings you back to the function you were integrating. So the derivative of this integral is the function that you just integrated. All right. I know that probably sounds weird. I'm going to keep going. So we're this is what I'm going to do. I'm going to put 4 of these up here. All right, so for this one right here, so f, uppercase f of x, we'll bring the -4 out, we'll put the integration symbol, and that's x to the -3rd power dx. So now we start the integration process. So it's -4 times that. Remember to put the plus c so you don't forget it. Indefinite always means the plus c. So then, -3 plus 1. Well, -3 plus 1 is -2, so you divide by -2. -4 divided -2 is +2. And then -3 plus 1 is -2. Remember, we do not like negative signs. So this becomes +2 over x squared plus the capital C. And again, if you do the derivative of this, you'll end up getting that. All right, so let's do this one. That really says -4 over 1. So we're going to bring out a -4, and then that's going to be 1 over x cubed. Well, we can write that as x to the -cube dx, and then you're going to do exactly what we just did a second ago. This right here means the exact same thing as that right there. So then you just take this and you follow those steps. All right, I'm going to undo this. Okay, we pull out a -5/3 on this one. We write the integration symbol, and then that is x to the 2/3 times dx. So f of x that's x to the 2/3 plus 1. So 1 is 3 over 3. Well, 2 over 3 plus 3 over 3 is 5 over 3. Whoops, I didn't put the plus c. Should do that. Well, we don't want a fraction in the denominator, so we're going to multiply. I should do that in red. By the reciprocal. So then I have to multiply up here by the reciprocal. So now what I have is 3/5 times -5/3 leaves -1, and then that is x to the, well, 2/3 plus 3/3 is +5/3 plus c. All right, you're going to rewrite this as x to the 1/4 power. So we're going to bring out the -5. Now I'm going to write that as x to the 1/4 dx plus c, and then that's x to the 1/4 plus 1, which is 4 over 4. 1 plus 4 over 4 is 5 over 4. So we're going to multiply top and bottom by the reciprocal, so 4/5. So here we're going to multiply by 4/5. So that leaves -1 times 4 is -4, and that is x to the 5/4 plus c. The other way to write that, and some professors will want it written, is to rewrite this back as radicals. So 5 is the exponent, 4 is the root. So it'll be the 4th root of x to the 5th. Sure to close the parentheses, then put the plus c. So this notation right here and this notation right there, it means the exact same thing. All right, I'm going to stop this video here. All right.